Alright, so, I've complained about Northrop arrow notation and all kinds of fun things. So, what should math look like? So I'm thinking the base thing, the thing that you always need to start with, and you always need to be mindful of, is the definition of your units, right? So that's really at the top is your units. That's the first thing, right? This is, if we're counting correctly, this is your zero position. This is where you start from, right? And this is outside of the scope of mathematics, sure, but this is where you start. You need this. You require this. Once you have units, then you can move on to incrementation. Okay? So this is your first thing that looks like a mathematical operation, incrementation. But we should note that it has an inverse, decrementation. Okay. This is something that is not handled with systems like Northrop arrow notation. What is the opposite? What is the inverse of whatever level we're at? And we're still at a level that isn't even noted in classical mathematics. Right, we have addition noted as iterated incrementation, but we're not noting incrementation as an operation itself, even though we're iterating it to get addition. That's dumb as fuck. But you can't even do incrementation until you have units. And if you can do incrementation, you can do decrementation. They're just, they're signed opposites. Okay, and then what happens here? Incrementation gives us access to numbers. Okay, so from here we get numbers. Units are required in order to perceive anything, in order to ever count anything. And counting stuff is what allows us to see numbers. Okay. Incrementation gives us numbers. Incrementation requires units, and incrementation's opposite is decrementation. Okay? So now we get what is considered generally the first level of arithmetic, addition. So this is iterated incrementation or the use of numbers. Now, something important is happening here, because now that we have numbers and units, we can do something like take a measurement. And measurement is how you get, like 7. Shit like that, right? Without a concept of numbers and without measurements, you're not going to be able to do addition, right? The only thing you can do without numbers and measurements is incrementation. Okay. So, all of this stuff that's happening up here is built into the assumptions of mathematics, like what's required, but nobody will state this. It's not, it's definitely important, it's definitely required, but nobody's going to say it this way. Okay? And then addition's opposite is subtraction. Okay? And again, in order to do subtraction, you need numbers and you need measurements. Okay. Then, if you iterate that, you get multiplication. Oops, that's an L, that's a T. Sure. And the division, the opposite of that is division. Sometimes I can spell, not today. And then if we iterate that, we get exponents. And if we iterate division, what do we get there? Oh, about logarithms. You might say roots. Roots feels like an opposite of exponents, but roots are actually just fractional exponents. So roots are exponents. Logarithms is really the natural opposite of exponents. Knuth arrow notation kicks in here after we've established all of this other shit. That's where Knuth up arrow notation kicks in here at this stage. Are you fucking kidding me? And our typical vocabulary kicks in here, right? Because this next step is tetration. I don't even know if there's a word for what happens over here. So, I don't know. And there's definitely not, as far as I can tell, there isn't a notation to handle what's going on over here. So, we're counting this as 4 tetration, and then pentation, whatever. Right. Etc. But here, it's just a long string of. What are we doing? So there's a hole here, for sure. We're considering this the 4th level, but if we count 4, 3, 2, 1, 0, -1, we did it wrong. You should end at 0. This should be your 0th level. So incrementation should be your 1st level. Addition should be your 2nd level. Multiplication should be your 3rd level. Exponents is your 4th level. Tetration, which is called 4, should be your 5th level. Right? This is the way it should be. It should be 0, 1, 2, 3, 4, 5, 6, etc. And over here you have, it's opposite, right? So that's -1, -2, -3. You could call it whatever you want. I'm just using the negative to indicate that it's the opposite. But I feel like if we ever encounter an alien intelligence and they see the way we do math, they look at our formalisms, they're going to be like, how fucking retarded are you? What the hell? You don't understand what you're doing? Because, this is non-negotiable. This is how it has to work, right? You have to define units in order to be able to do anything, okay? And incrementing units and playing around with that and systematizing names for certain levels of incrementation is where you get numbers from. Here, there are no fractions. There are no irrationals here. There are no imaginaries. These are numbers that you can count to with incrementation, okay? And then once you have that, we can take measurements conveniently with them, or with the incrementation. So, incrementation can sort of short-circuit your numbers. You don't necessarily need this to be able to take a measurement. You can just use incrementation to get to your measurement. But one way or another, you're going through this stage to get to measurements. And then, in order to be able to do addition, multiplication, any of this, you have to be able to take measurements. In order to take measurements, you have to have a sense of incrementation. In order to have incrementation, you have to have a sense of units. This is non-negotiable. This has to be here. But we're counting, this is our 1st level of math. Are you high? What are you doing? Are you serious? What is wrong with you? And we've developed notations and names and things for this branch coming out here. But even though we're fully aware that there is the inverse, right? Addition's inverse is subtraction, multiplication's inverse is division, or as I wrote it, multiplication, because I'm an idiot, is division. Exponents inverse is logarithms. Do we even? There probably is. I'm sure somebody's done something over here, but it's not something I've heard of. And I've probably heard of more math than most of you. So the fact that I don't know about this, or this, or this, is not a good sign, right? This is certainly not a casually known thing. This is not a casually even known thing, really, even, right? But this is much more casually accessible than, if anything is over here, what the hell do we call it? How do we notate it? What the hell is going on over here? I don't know. I kind of doubt this has been done, but yeah, I feel like there's problems here. There's problems here, because if we're calling this level 1, and there's 2 levels above it that it's based upon, at least, unless you consider measurement to be a level, which is a fair call. It's fair to call measurement a level. I mean, addition is at least level 2 or 3. Right? And here, numbers, they're really outside of math. Everything that math is built on is units up here. Units. But in school, of course, you're taught that it's about numbers, and you're falsely taught that things like 7/3 are numbers, right? They're not. They can't be. Not possible. Because the way we got to numbers, every language on the planet that has numbers, that talks about numbers, got to them this way. And then formed generalizations of how to deal with them, right? So you might have something that's like based on the number of digits on your hand, or you might have something that's based on the spaces between the digits on your hand, right? So you might have a base 4 system, or you might have a base 5 system, or you might have the spaces around the digits on your hand, so you might have a base 6 system, or all sorts of other things might, you might count your fingers and then your joints coming up. So like by the time you come around to the other hand, you're at like 20 or something like that. Like, these are all ways that human beings have figured out how to count and deal with it, but it always involves incrementation. So it's very strange to be like, oh yes, we're so smart. We got past the level where we think that numbers are just 1, 2, 3, 4, 5. No, you're not smart, because you can't even count the levels of your own bullshit. You're counting this as level 1. That's wrong. You're counting this as level 4. It's at least 5. This is at least level 5. This is non-negotiable up here. This has to be up here. This is foundational to this. This is how it grows. Non-negotiable. You have to have units. You have to develop incrementation in order to do anything. But if you notice the notation on incrementation, it's the same as the notation of addition. Right? You have plus. But the one that you're using in incrementation is different than the one that you're using in addition. That's a different thing. Why is the notation the same? Completely, exactly, 100% identical, when they're actually different things. That's interesting. The way that our formalisms for mathematics are really, really weird and broken. And, it's long been an interesting thing to me that you'll see claims that mathematics is like a universal language, and if we were to contact extraterrestrial intelligences, that they would recognize math. They would recognize math the way that we do. I don't know that they would. I think they might see what we do and laugh at us, because the way we do it is quite honestly blatantly stupid.